Hello and welcome to another video. In this one, we're going to be talking about zero argument arrays, which I have previously discussed in another video, this Python try, except, and best practices video. So check this one out if you want to learn more about the other parts of try, except. But we're specifically going to be talking about zero arg arrays today and how it works and why you would want to use it. But that'll be in the description if you want to check that out. All right, so when I talk about zero argument arrays, this has come up a few times on stream while I'm working on particular projects. For instance, the auto updater for pre-commit CI uses this. And the syntax looks something like this. You'll see just a raise statement on a line with no arguments after it. And in fact, this one has two zero argument raises. At a high level, what raise does is it re-raises the current exception. So it makes it look as if this except block had never existed at all, and whatever thing caused the issue will, raise out as before, not modifying the stack trace at all. As opposed to doing something like raise E, which will create a new stack trace, and in Python 3 it'll have a change stack trace. You'll see the original stack trace, but you'll get a new stack trace that starts at this frame here. And so you generally don't want to do this like ever. You almost always want to just use zero argument raise, and I'm going to show you a few examples of this and then show you how the code works to make that happen. Let's not modify that there. Okay, so we are going to make just a very silly example today. We're going to implement os.makeDirs, which has an existOK argument. Of course, you wouldn't actually do this yourself. You would just use this function, assuming you're on Python 3, which of course you're on Python 3, right? But what makeDirs does is it allows you to create a bunch of directories at once in a nested directory structure, and if they're already there, it will do nothing. So this is an idempotent call. And we did another video on idempotency, so I might remember to link that one in the description. If not, you can just search the playlist and find it yourself. Idempotent, so you can check out that video there. Okay, so we're going to make our own, we're going to call it makedir-p after makedir-p, which is what we're simulating, but in Python. It's going to take a directory name as a string, and it's going to return nothing. And so it is going to try and call os.makeDirs, but makeDirs didn't always have that existOK argument. This is what it was like in Python 2 and older versions of Python 3. And we're going to do except os error. And we actually don't need to know the name of the os error. We could inspect that, maybe do some logging, something like that. I go over more of those reasons that you would want to re-raise in the other video. But in this case, we only want to re-raise if we got some unexpected error and this directory doesn't exist. So if not os.path.exists, well, actually we want isdir because we're making a directory. If it's not a directory, we will re-raise the original exception out, whatever this os error was. And again, we're using zero argument raise here, as opposed to doing something like this, which would create a new exception stack trace. Let me actually show you the difference between the two. Let's make a file such that making a directory with the same name will fail. To makedir-p foo/bar. This is the case where we re-raised our own separate exception here. And you'll see that the top of the stack trace is our raise line rather than the actual error, which comes from os.py. This is the actual stack trace that we care about here. But instead, if we use the zero argument raise here, and we do the same thing, you'll see that we don't get that raise line at all. It is just our calling code here. We don't have this kind of confusing, weird stack trace where we have these frames that don't really make sense. I'm actually surprised we didn't get a change stack trace. That might be because we're in interactive mode rather than actually running, and that's why we have this standard in frame here. But I kind of expected a chain stack. Whatever, it doesn't really matter. The important part here is, you want to use just zero argument raise because otherwise you get these confusing and annoying frames here. Okay, so that's how you would use it and what the syntax would kind of look like here. But I was also curious how this worked, and I know the way that it used to work. The way that it used to work is there is this attribute in sys, there is this exception info attribute, and this is where Python will store the most recent exception that has happened. And so what zero argument raise in that case would do is it would retrieve, the most recent exception from this, from the globals in the sys module. It's like a last, where is it? like a last exception or something in here. I don't remember where it is. Should we probably just do adder indersys for adder indersys if exe in adder. Maybe it's gone. Maybe that was a Python 2 thing. Adder for adder indersys if adder. Yeah, so this is where it used to be. There was like exception type and there was exception instance and other stuff that were just present on the sys module, and that was kind of the global variable for the currently raised exception. But this changed in Python 3. Python 3 changed the currently bubbling exception to be part of the frame information, if I recall correctly. So now it's implemented directly in the bytecode. So we're going to take a look at that bytecode. Again, I did a video on the bytecode, so I'll link that in the description, but Python is actually compiled. And this is the name of that video. Python is compiled, so I go over the disassembler in more detail in that video. But we're just going to use this quickly here. Oh, there's a lot of code here. Okay, so I think most of the code is around this setup finally. This raise varargs, this is where our 0 argument raise is here. And this is what's going to cause us to do the re-raising there. Let's actually look at Python 3 dis, which I've looked at before. And if we look at raise varargs, raise is an exception with 3 forms of the raise statement. They don't put too much detail here. It says 0 raise from the previous exception. Let's actually take a look at the implementation in CPython, since that's not that useful. Also, this has changed recently. If we look at the 3.11 docs, I'm pretty sure exceptions have completely changed. Like, I don't think there's a finally setup anymore. Yeah, like there's no setup finally. This opcode is just completely gone. So exceptions are going to change in 3.11 a little bit. But let's actually take a look at 3.10 instead. And I happen to know that it lives in this ceval.c file. This is where the main event loop of Python lives. And you can take a look at 3.10.1 rather than 3.11 because this has changed and I don't know how the new one works. But if we look at setup finally, for instance, PyFrame block setup. Yeah, here we go. This is what we want to do. So this is the exception unwinding code, and the way that it works is there is some frame information that's stored into our execution stack, which has the traceback, the value, and the type if it's not null. Otherwise, it pushes none. And this is how the exception state is stored. So then when we run the raise varargs, here, you'll see that under case 0, which is our re-raise case here, it's going to do this do raise thing. Going to do raise now. Actually, it's going to do it in all those other cases since we have implicit switch case fall through here. But do raise is going to grab the exception info out of our stack, our thread state, and then re-raise it. So it's stored a little bit differently. There is still that sys.exception info in Python 3, but it's stored in thread state information rather than globally on the sys module. So it's a little bit different. But basically, it's going to take the triplet, the type, the value, and the traceback, and just propagate that upwards and continue raising out of this function. So it's going to keep the original traceback rather than making a brand new one, which is what that raise 1 would do here. So this is in the case exception is null. But yeah, in the case 1, it's going to grab the exception out of the out of our stack. So if we look at here with raise e, this, you'll see here. Yeah, we do load fast e, and then we do raise varargs 1. So this is going to say pop 1 item off the stack, which is this e variable, and then re-raise it. So that's kind of the difference that happens there. But the take home here is 0 argument raise is going to preserve the original stack trace, and not add any new mysterious frames here. And it's generally what you want to use if you are re-raising an exception. You do not want to do raise E. But anyway, hopefully you found this interesting, and this is a little bit advanced. Some of this is over my head too, so I wouldn't worry too much about the bytecode stuff, but figured I'd poke through and show you how it works behind the scenes in CPython. But anyway, hopefully you found this useful. If there are additional things you would like me to explain, leave a comment below or reach out to me on the various platforms. But thank you all for watching, and I will see you in the next one.